Hey everyone, it's Matt with Spiceworks. Thanks for joining us on another Spiceworks Partner webinar, SMB 3.0 and ScaleOut File Server for Microsoft environments enabling Hyper-V and SQL Server performance. Brought to you by Starwind Software. First, I'd like to remind everyone of a few things. There's a Q&A box on your screen to the left. Please don't be shy. We really encourage questions. This is a great chance for you to get insight from some real experts. All you do is type in your question and click Submit. But if your question isn't addressed live, Starwind Software will be able to follow up with you. Another thing to remember is that we are recording this webinar. So if you have to step out for a bit, it's no big deal. You'll get a link to this recording in a few days. It will be an on-demand presentation, so you can check it out as many times as you'd like. And that's about all I have, so now it's my pleasure to introduce our presenters. First up, we have Greg Schulz, founder and senior advisory analyst from StorageIO. And he will be joined by Max, virtual SAN product manager from Starwind. So Greg, take it away.
Hey, great. Thanks a lot, Matt. Great to be here with everybody today, and thanks also to Max for joining us on our conversation about SMB 3.0 and ScaleOut File Server for Microsoft environments, enabling Hyper-V and SQL performance. A couple of points here real quick. This is what we're going to go over for today. I don't want to spend a lot of time on this, but just, we got a couple of logistics things to go over, some of which Matt already talked about. We're going to talk about some trends, perspectives, the big picture. What's going on with the software-defined tiered storage flash, solid state, locality of reference. In other words, the issues, the problems that are associated with the need for using technology such as Microsoft ScaleOut File Server to address Hyper-V and SQL performance. And we're going to dig into it more. We'll take a look at ScaleOut File Server, SMB 3.0, and some other things along with some Q&A intermixed here. Again, some of these Matt already went over, but I just want to repeat a couple of them as a reminder. You can download this presentation. There will be a hard copy, a PDF available. It is also being recorded such that you can come back and check it out later. Also watch for other StorageIO as well as Starwind events and activities. Follow us all on Twitter, participate, ask questions today as well as follow up. Also, visit the StarwindSoftware.com site to learn more about what we're going to talk about. But one of the things I want to highlight here is the fact that Max is going to go into some details about Microsoft SMB 3.0, and there's a whole nother deep dive presentation that Max has available over on the StarwindSoftware.com site. And oh, by the way, while you're at the Starwind site, download a copy of Starwind Virtual SAN, put it into your own live lab environment like what I've done, and leverage it. Take advantage of it, use, learn, all those other fun, good things. So with that in mind, let's just keep moving along here real quickly. Who am I? I am Greg Schulz from StorageIO. My contact information is here. I'm on Twitter at StorageIO. My site is StorageIO.com. My blog is StorageIO blog. I've been the customer. I've been the vendor, analyst, author, advisory consultant. In my spare times, I've written a whole bunch of books. All around server, storage, I/O networking, hardware, software, virtualization, applications, business resiliency, and all these other things that I think are fun. But, hey, I want to bring in my guest for today real quickly. Max, are you there?
I'm here, Greg. Thanks for a great intro. Well, definitely. The audience is really in good hands today. Greg has worn nearly any hat you could wear in the IT field, so we definitely have an expert here. I'm a bit shy, so I'll just say I'm Starwind Virtual SAN Product Manager, and I've been in quality assurance and technical support in Starwind before, which gives me about 7 to 8 years experience in Starwind and in storage field. I have more than 10 years, so I started doing storage a while ago, and then I focused on it completely, as you can see. I'm also hosting Starwind Technical Webinar Series, and as Greg mentioned earlier, I did another event on the ScaleOut File Server, which you may be interested in for a deeper technical dive. So, yeah, here's a small Starwind profile. We're spun off from a company called Rocket Division in 2008. Right now, we're privately held. We've got 3 big investors, and there are more coming. We're primarily working on Starve and Virtual Send products. We've got more than 250,000 paying and playing customers worldwide, based out of Boston, Mass. There are more than 60 right now, so I would say not 50 plus. We just hired a few more people. We provide global 24/7 technical support, and we're partners with most of the big IT players on the market. So with that, I think I'm wrapping up my part of the intro and handing over to Greg.
Hey, great. Thanks a lot, Max, for that quick intro, both of yourself as well as for Starwind. And it's also great having you along here because I know that you're able to go deep into these different technologies, these different things. But you know what? Before we go into the deeper things, how about we just take a real quick step back and just set up the discussion about why we're here, what we're going to talk about, so that some things here hopefully start to connect. We want to make this understandable, but we also want to get into the technology a little bit. So a couple of quick general trends here are, for example, there is no such thing as a data or an information recession. This is all about there's more data that needs to be served, processed, moved, etc. However, there are the economic challenges, there's budget constraints, other budget issues, regardless of the size of your organizations. Also, everything is not the same for different environments, whether you're a small SMB, whether you're a medium SMB, whether you're a medium enterprise or a large enterprise. There are a lot of commonalities, but there are different requirements, different needs, performance, availability, capacity, budget constraints. So what this all sets up to is the need for your IT environment to be flexible and to adapt to the different needs. This is where the idea around software-defined management and virtualization comes into play as a tool to help enable, as a tool to help do things, as opposed to having a tool that the business or the organization has to adapt to. This also means to help stretch budgets further is to remove complexity, remove costs, both operating and capital upfront as well as recurring. And this is also where we see some of these technologies starting to step up to the plate, such as converged, hyper-converged, as well as simply using new and old things in new ways. Okay, looking at that a little bit further, part of what we're looking at here then is, as I mentioned on that last slide, we got to start using new as well as old things in new ways. And what I mean by this is that there's often a tendency to take whatever is new and simply use it in old ways. Whether it is using some new hardware and using that in an old way, or some new software and using it the way things have always been done, those are all part of the equation. Those are all things. And the main theme there is we got to start using both new and existing things in new ways, as opposed to simply repeating what's been done before. Now, part of where that comes into play here is to stretch your budgets, to go further, to do more. And as a part of doing that, it's not just simply talking, or it's not simply leveraging software-defined for the sake of software-defined, or data footprint reduction because it's a new tool or a new capability. What it also means is being able to leverage the different technology, but get the technology to start working for you. Okay, so let's get to the heart of this, is that as we look at different environments, there is the need to start addressing I/O footprint reduction. We talk about data reduction, data compression reduction, but we also have this need to optimize different performance. In other words, leverage caching, leverage DRAM, leverage solid states to boost performance, but find and address different bottlenecks. I'm going to try something here just in case the audio isn't well. We'll see if this helps make things any better. For those who are commenting about the audio, if this is good, just say it's good. Otherwise, I'll go back to the headset. So we're going to wing it here. Okay. The other trend here is about scaling. They're scaling up, going with faster servers, faster processors. There is scaling out, adding more. adding more capabilities to what we're looking at here. And okay, go back. That's what we see. Okay. Hello? Okay. Well, I don't know if you can hear me or not, but if you can hear me, say yes. Whoever's typing. Brian Cunning, does that sound better? Max, can you hear me?
I think you sound a little quiet now. So something happened when you transitioned back to
further, let's see if we can figure this out. Max, can you hear me?
Yes, a little better.
Is that better? Okay. Here, I just threw the headset out the window. Is that any better?
Not really. Any way you can get closer to the microphone?
You know, if I put it any closer, it's going to be inside my mouth.
Oh, yeah, because it sounds like you're tied to a big storage box, and you're trying to get to your laptop and actually do the webinar.
What's that?
No worries. Okay, gentlemen, we're sorry for the intermission. We're trying to fix the audio issues with Greg here, and I think Greg just became a little louder. So just give us one last comment.
Yeah, let me. Can you hear me? Okay.
Yeah, I can hear you well.
Okay. Sorry if you can't hear me. This is all the louder I can talk without actually yelling any louder than I am. So apologies for the bad audio. Anyway, let's get back on track here. We want to talk about scaling up, scaling out, and scaling down. One of the things we want to address here is the fact that scaling up means going with faster hardware, faster servers. Scaling out means adding more of them, but scaling down is just the reciprocal of that, going smaller here. Anyway, what we want to look at here is another theme that ties back into all of this, which is the idea of locality of reference. Keep in mind that storage is persistent memory. There are different tiers of storage and different tiers of memory. The best I/O is the I/O that you don't have to do. The second best is the one that has the least impact. What that means is if you can do your I/Os from the server, if you can resolve those I/Os from the memory cache, from the layer 1, the L2, L1 caches using DRAM, that's great. But we have to also keep in mind that we need that persistency. So anyway, let's jump on from locality here so we can keep things moving and get into Windows Storage Server, ScaleOut File Server, and other keywords and buzzwords so we keep things going. Okay, so here's what's new. For those who aren't familiar with Windows Server Storage, there's this new thing out there. You got 2012, you got R2. Here's the bullets. You can do better scaling. You can leverage storage spaces enhancements. You've got solid state for write-back cache for doing that better caching, for leveraging the locality of reference and all that other fun stuff for I/O acceleration. You also have new resiliency options, triple mirrors, dual parity, granular server-side dedupe, and you also have enhancements to the ScaleOut file server along with SMB 3.0. Okay, so Max, why don't you take over for a bit and talk about SMB 3.0?
Yeah, definitely. So right now, Microsoft considers SMB 3.0 and ScaleOut file server as the future network storage protocol. The reasons for that are multiple. They're not so simple, but we'll try to get an overview of them. I'll try not to get too technical here and just try to explain the basics. So with SMB 3.0, Microsoft completely controls the specifications and development. So features they want to implement get implemented faster and accepted faster. So with less iterations and less work from Microsoft to adopt something other storage vendors are doing, they're actually doing a good thing. So basically things like SMB Direct, SMB Transparent Failover, etc., they're very fast implemented compared to ones you can get from iSCSI arrays or fiber channel arrays, like ISER or iSCSI over RDMA, multipathing, and stuff like that. Then NTFS and essentially CSVFS has some performance implications if iSCSI storage is used by multiple initiators. So it is not a true clustered file system if we compare it to VMFS, which is truly clustered. So when there are more than 2 writers to a single volume, there can be some issues with CSV ownership or NTFS locks moving from one accessing node to the other accessing node. And now Server 2012 R2 and Hyper-V 3.0 combination with NTFS and CSVFS is much better than 2012, but still there is a way to do better. So Microsoft tries to leverage it to a whole new level, abandon the block level, make it more simple for the customers, make it easier for the customers, and drop the legacy issues with old way of doing storage and introduce something new, which makes more sense. Now, one more bullet point here is ScaleOut file servers offer more flexibility by using commodity hardware as front end and still allow to do backend fiber channel and SAS infrastructures. You can also use iSCSI technically. You can use any other storage, but I would say that 2 primary candidates for being front-ended by ScaleOut file server are SAS, and second candidate, which is kind of falling out right now, is fiber channel, but primarily SAS. There is one more thing we haven't mentioned here. Microsoft likes the idea to control storage and compute layers separately. So they try to segregate them to give you more flexibilities. Okay, you've got 2 Hyper-V node cluster environments. You want more performance, you throw in one more SAS JBOD, you get more performance and you get more capacity. You want more virtual machine performance for the new applications or more virtual machines, you can add one more Hyper-V node and that does the job. But there is actually no one-size-fits-all here, so we'll talk about it a little bit later, because this approach is not a panacea for an IT world. Now, at the end of the day, Microsoft sells Windows licenses. So with ScaleOut file server, they do a convenient way by providing a storage appliance, which is a really good thing as well, because the storage vendors can now gate all their storage through the ScaleOut file server and have all the features written by Microsoft, and they'll all be supported. So Greg, at this point, we're going further, and we'll see about Windows Server storage and a little wider look at the options we have.
Okay, real quick, Max, let's take a quick look, and we'll come back to you to dig in this a little bit more. Is for those who aren't familiar with ScaleOut file server, it has been designed to support Microsoft Hyper-V and SQL Server. The idea is to help accelerate, to help optimize workloads such as those, and those in particular, Hyper-V and SQL Server, that have demanding I/O workloads. So part of the idea around ScaleOut file server is that it should be easy to scale, both performance, availability, as well as resiliency, beyond your standard local and network shares. Part of the idea, too, is that it adds new resiliency capabilities while enabling scale up as well as scale out beyond traditional capabilities. You can actually scale up to 64 nodes or up to 16 by 4 node deployment elements. So you can actually scale quite a bit for those of you that need to scale up, okay? But as I mentioned a little bit ago, not everything is the same, and some of you need to scale down. Well, what that means is having that flexibility where you can scale something that has high performance, that has resiliency, that has availability, be able to scale that down, but also to be able to scale the overhead, scale the amount of hardware that you need down as well. So what this all means is that ScaleOut File Server, or SOFS, combines several different things. Here I want to give you two examples on this particular slide that shows two different environments. Before, on the left, not using ScaleOut File Server, and on the right, using ScaleOut File Server. On the left, you got your basic capabilities. You can use it for aggregating different workloads, but what about how do you address performance bottlenecks that are introduced as a result of aggregation? Over there on the right, we see using ScaleOut File Server in two models, both with Hyper-V as well as SQL Server, and it's simplistic. Well, the ScaleOut File Server gives you the performance optimization and acceleration for SQL Server as well as for Hyper-V. It provides the foundation for scaling. However, what about clustering? What about shared JBOD? What about shared direct attach storage? What about sharing PCIe flash and RAID cards, not to mention RAM? This is a segue where I'm going to throw it back over to Max and let you jump in now and comment a little bit more about scaling with ScaleOut File Server, but doing it without increasing cost and complexity, i.e. taking out overhead. Max?
Sure. Yep. So we're going to the next slide we have. On this slide, we have a traditional ScaleOut File Server backend environment with two Hyper-V hosts in a cluster as our front end. So the gray rectangle is actually the storage backend we have. As you see, we've got 3 JBODs, 2 SAS switches, and a SAS HBA connected to each of the ScaleOut file servers. The idea here is to provide a minimum redundant configuration. So clustered storage spaces enclosure awareness requires the 3 JBODs. So 2 will not be sufficient here. 1 is working as a witness. 2 SAS switches are actually optional. They can be omitted, and you can do a direct connected setup where you have 2 HBAs in each host. So both JBODs are connected. Well, all 3 JBODs are connected to both servers. But I've drawn it out with the SAS switches just to make sure we're covering the scaling part more or less, where we can just add more JBODs or ScaleOut file servers or the Hyper-V hosts to the environment. So the idea here is to use SAS storage and then present it as file level storage for Hyper-V on the high level. On the low level, ScaleOut file server gets the raw storage from the JBOD, creates clustered storage spaces, and then puts CSVs on top of it and uses those CSVs as continuously available SMB3 shares for the Hyper-V host or SQL host. Right now, most of the workloads are getting virtualized, so we're considering our SQL hosts properly measured and virtualized properly so they have good performance. But back to our gray rectangle. The hardware here is an additional layer which you can scale, which is definitely a good thing. But there are some limitations as well as some caveats with scaling this hardware. First of all, the minimum redundant number of JBODs here is 3. And to get it highly available and scale further, you may need additional 3 JBODs or have the 4th JBOD and then just do cross-mirroring and cross-creating clustered storage spaces between different enclosures to still maintain the enclosure awareness and be able to tolerate 1 or 2 JBOD failures. Then there are the SAS switches, which add some proprietary equipment to the setup. and then there are the SAS HBAs on the system. So for me, this is a good setup because it is really storage oriented. It does just storage. It doesn't do anything else. But there is a vendor lock-in here, since there are not really a market yet for the JBODs, and there is not yet a developed market for the SAS switching and SAS HBAs. So this market is definitely developing, but for now, jumping on this train doesn't really give you any options for changing your route or going back. So this is something to consider. Now, one more thing about this configuration is that this locks in on the protocol you have. Sorry, this not really the storage protocol, but the actual disks you use. Let's say any JBOD can use SAS, but should we decide to go for PCI Express Flash, or if we want some cheap but fast storage, maybe use some SATA-based SSD disk, this is not something we can do with JBODs. So right now, leveraging that type of storage is not really possible with a traditional scale-out file server setup. Now, in an alternative configuration or a complementary configuration, this is something for the actual user to decide. The scale-out file server config is converged with the storage. So right now you see that the gray rectangle is out of the equation. We now have our directly attached storage to be mirrored by two scale-out file servers and then presented to the same Hyper-V host as block level, file level continuously available SMB3 share. And what StarWind does here, StarWind allows that mirroring of the directly attached storage resource. But that's just a high-level overview. If we get a little deeper, we also realized that before we just had the storage layer and then we had the scale-out file server layer. So there was a gap and sometimes a bottleneck between the storage and the front-end file server presenting it. Right now, all the storage we access is local, so we get the most performance of it. We can use the PCIe flash storage. We can use the SATA flash storage. We can use any hardware we want and still expand it with the JBOD configuration. At this point, StarWind can help storage spaces and just use one JBOD on each end and use it as its local storage to expand the capacity of each node. And moreover, StarWind adds that write-back caching, which scale-out file server may lack for some time. I think Microsoft will release it soon, but for now, StarWind adds that mirrored write-back RAM caching between the servers, and it also adds distributed flash caching between the servers. So at the end of the day, you have a self-contained scale-out file server within just two servers, scale-out file server cluster within just two servers, and you can still use your existing JBOD configuration, but add more resiliency to it and add more performance, because you can now use your local storage. You can now use standard 10 gig cards to mirror that storage. You can still enjoy all the features of SMB3 and scale-out file servers. You can still scale and maintain resiliency with less items in your configuration compared to the classical one. Now, there is a little table I've left for the end where we have minimal hardware requirements and scalability comparison between the compute and storage separated, which is our diagram with a gray rectangle, and hyper-converged, which is the Starwind-based configuration. So the minimum number of servers in the architectures is 3 for the classic environment. So I've written 3 and inverted pyramid here, just where compute and storage separated. You've got 2 Hyper-V servers to get a Hyper-V cluster, and then you have 1 scale-out file server presenting the storage. And essentially you have a JBOD, but I haven't considered it as a server in this equation. A hyper-converged environment instead requires just 2 hosts, which are self-contained and fully redundant. So the storage here is highly available. It's not an inverted pyramid because right now we have 2 storage instances and not just 1. And should one server fail, the second one will continue to work. Then the second row here is minimum number of servers for HA cluster. So a minimum number of servers for a Hyper-V cluster is 2, the same for the scale-out file server. This gives us 4 servers as our compute layer and as our storage processing layer, and then there are additional JBODs required for actual data storage. With Starwind, I would say that at this point it's not 2, it's a mistake on the slide. It's 4 servers, and these 4 servers have highly available Hyper-V cluster, and they have highly available scale-out file server cluster with self-contained storage, which is mirrored between 2 servers. Now, with next thing here is RAM caching. So with scale-out file server, we do separate RAM cache from the Hyper-V host. From the scale-out file server host. With the hyper-converged configuration, all our caches are server-side, so we never bottleneck our cache with a link between the servers. Same happens for the flash caching. If it's local, it always works faster. Now, cache effectiveness, as I mentioned earlier, bottleneck between storage and compute layer results in low cache effectiveness, and even with storage spaces caching, you don't really want that bottleneck between your server and your JBOD configuration. So right now this is covered by developing 12 gig SAS protocol, and this is coming into market, but instead we're trying to bring the cache as close as possible, so we just keep it local and synchronize it, keep it coherent between the nodes to get that level of resiliency and still have the best performance we can get from the configuration. Now, scalability of the traditional environment, well, let's just call it gray rectangle environment as a reference for this event, is nonlinear, which is both good and bad. You can scale different pieces of this configuration independently, so you can get one more Hyper-V node, or you can get one more scale-out file server cluster node, or you can get more JBODs, and this all gives you different perks to your environment. You can keep growing it from different sides, but that also introduces some management complexity, and it may introduce additional cost. Because if we compare it to a hyper-converged environment where we just add one more node for storage or add one more node for compute, or even if we create a third row in the comparison and say we just do, I would say, uber hyper-converged storage, so even omit SMB3 and just use Starwind and local storage mirroring, in both cases we get linear scalability of the configuration. And Greg can talk more about scalability. as soon as I finish, or he can actually interrupt me and say his ideas. I know Greg had a few more words about it.
Yeah, great. Thanks, Max, for going over that. Actually, can you hear me?
Yeah, actually, we can hear you better now.
Yeah, no, I'm getting an echo, but thanks for going through that, Max. That's good info and helps to see where ScaleOut file server fits with SMB 3.0 and with SolarWinds. Couple of items. Yeah, how about that? We are getting the echo. Somebody else heard it. Is a reminder, go to the StarWind site, starwind.com, starwindsoftware.com, and download a copy of StarWind software. Put it on your system, give it a try, experiment, work with it. Also, check out the other resources there, the other webinar that Max put together that digs deeper into what we've been talking about, what he's been talking and discussing here, along with other follow-up material. But you know what, we got a couple minutes for any questions if we have some, other than why do we have audio issues and how come we're getting such a interesting echo effect. Max, you got anything else that you want to say before we wrap up?
Not sure. So I would say that I would just wrap up with the scale-out part and say that you now see multiple options in terms of how you can proceed with scale-out file server. So that's definitely the tomorrow of Microsoft Hyper-V storage. And now you see multiple ways of moving forward with it. And also, if you want a more technical explanation of why the whole scale-out file server thing emerged, and some more details about the gray rectangle configuration compared to a hyper-converged configuration, on our website we do have a recording of my previous webinar, which is actually mentioned on the lower part of this slide. View Max webinar used Microsoft Storage best practices for Hyper-V and SQL Server, SMB 3.0 and scale-out file server. So that's an additional instance where you can get more information, and I'm always welcome to answer additional questions should you have them. You can either use the Q&A box within this event or just email them to support@starwind.com, and I'll gladly answer them for you.
Okay, great. So let's wrap up here. A couple closing thoughts is, look, everything is not the same. Not all environments are the same. They've got different needs, whether it's scaling up, scaling out, or scaling down. The key thing here is that what is common is many environments are using SQL Server or Hyper-V or both of them, and as you start to use them, keep in mind that aggregation, consolidation, aggregation will cause aggravation, i.e. bottlenecks. So you can either move, mask, or find and fix those bottlenecks, because the best I.O. is the one you don't have to do. The second best is the one with the least amount of overhead. And you can throw a lot of cache, a lot of solid state at a performance problem, but that's going to cost you a lot of cash as in money. But a small amount of solid state, a small amount of RAM cache in the right location, that's that notion of locality of reference that we touched on briefly, that's where that comes into play. And if you can find and fix the problem, that's part of stretching your budget, whether you're scaling down, scaling up, or scaling out, but it's also scaling without compromise. So do more with what you have. Look for solutions that adapt to your needs, that adapt to your business, as opposed to you having to adapt to their requirements. Understand your upfront capital costs as well as your recurring operating. Key is leveraging software management tools that enable you to address your issues. And learn more, as we mentioned, about SOFS, SMB3, StarWind software at the StarWind site. Let's see real quick here if we might have a question coming in. Let me just check. Anyway, that's all that I have for today. I'd like to thank everybody for attending. Apologize again for the audio. We went from faint audio to echo audio. What else can I say? But apologize for that. Thank you again for attending. Max, any closing words?
Yeah, so the story with the audio today, I'll just try to rephrase my standard wrapping up for the storage events. Right now we see that as soon as you're in production or you're on air, there is no way to change much. So plan your environment ahead and make sure that the storage you're purchasing and the storage you're deploying in your configuration works for you and provides you with the necessary performance. So things can fail, technologies can fail you, and that's why we deploy fault-tolerant environments. So right now, for the next webinar, once Greg throws his microphone out of the window, he should have a new microphone in the box on his table, just in case. So that's what we call real high availability, and fault tolerance here would be a microphone and an audio splitter for two audio systems.
Well, actually, the real solution is to get rid of the traditional telephone systems and leverage platforms that actually allow digital connections that then you can apply different codecs and things like that. But you know what? That's for a different conversation.
Indeed, we digress. Okay,
right.
So should you have any questions, we'll be glad to answer them in the Q&A box. And thank you very much for attending us today.
Great. Thanks, everybody. Again, this is Greg Schulz from StorageIO, Max from StarWind, saying, okay, enough said. Back to you, Matt.
Great. Thanks a lot, Greg. Thanks, Max. Hey, apologies again for the audio issues there. Just want to remind everyone that you will be getting an email here in a couple days with a link to view this webinar on demand, so you can check it out again, and hopefully if you missed anything, it will be in there for you. And hey, just want to thank each and every one of you for joining us today, and special thanks to Max and Greg. And thanks to StarWind for sponsoring us today. And with that, I hope everybody has a great afternoon, and take care.